So we're going to do question 9 of the 2015 paper 3 math A-level paper. So 2015 P3 math A-level. Okay, so it's a question about complex numbers. So this is a very useful topic if you're ever going to go into engineering or physics. And there we go. So the complex number 3 minus I is denoted by U, and its complex conjugate is denoted by U star. Okay, so they want us to plot on an organ diagram with an origin O the point ABC representing the complex numbers U, U star, and U star minus U, and then say what type of quadrilateral we obtain. Okay, so let's do this question. Well, let's zoom out. So U is 3 minus I, where I is square root of minus 1, and U star is 3 plus I, and this is just the definition of the complex conjugate. So you change the sign of the imaginary part. Okay, so now U minus U star is minus of 2I. Okay, so we can plot this on this diagram here, and we can clearly see that OABC is a parallelogram. Okay, and this is clear because these two sides are parallel and of equal length, and these two sides are of course parallel and of equal length. There we go. And what I need to underline here is draw with a ruler. And actually measure out those units. So 1, 2, 3, 1, 2, 3. When you do it, actually measure out the units so that when you do it in the exam room, your diagram is very clean, first of all. And second, you can see the trends immediately. So you can see, without even checking, that the length of OC is 2, the length of AB is 2. So then you immediately know that it's a parallelogram. Okay, so part 2 is show your working and express U star over U in the form of x plus iy, so in the form of a single complex number, with x and y being real. Well, okay, let's zoom out. Well, U star over U is 3 plus I divided by 3 minus I. So multiplying the numerator and denominator by 3 plus I, we obtain this part here. And this, you can quickly do these calculations if you realize that U conjugate is simply equal to the real part of U squared plus the imaginary part of U squared. And this is the same, of course, as the real part of U star squared plus the imaginary part of U star squared. So that's how you get the denominator. So again, this is 3 squared and then minus 1 squared. There we go. So simplifying further, we get multiplying out the brackets, and be careful with I times I, this is minus 1. Then you get 9 minus 1 plus I, and then 3 plus 3, so here. So this is your final answer. And so x equals 4 by 5, and y equals 3 by 5. Right. So the next part then is, by considering the argument of U star over U, prove this relationship. How do we do this? Well, at first this seems a bit abstract, but they give you a hint to look at the argument of U star over U. So the argument of U star over U equals to the inverse of tan 3 over 5 divided by 4 over 5, and this is tan inverse of 3 by 4, which is the left-hand side of the relationship. And how do you get this? Well, you know that you can draw a little organ diagram with 4 by 5, 3 by 5, this is imaginary, this is real, and this is your complex number, u star by u, and this is your angle. This is argument of u star by u. And let's draw a circle on this diagram. Right. There we go. So now, where do we get the tan inverse of 1/3 and tan inverse, the 2 tan inverse of 1/3 in the question? Well, we know that argument of u star over u is argument of u star minus argument of u. And if you require a proof of this, well, here comes the proof. Let me do it. So that part is one other part. Let me do it here. So you know that you can write u as u e I arg of u, right? Where this has to be in radians by using Euler's relationship, where u is a complex number, so u is a complex number, right? So then u star by u is just u star divided by u e I, and then using exponents, you get arg of u star minus arg of u. Right? And that's exactly what you get, right? So the argument of this is given here. So let's go back to our question. Well, arg of u star over u is equal to arg of u star minus arg of u. But arg of u star over u is tan inverse of 1/3 minus tan inverse of minus 1/3. Okay, which brings us to the diagram which I showed you here. So there we go. So tan inverse of 1/3, so this length is 3 right here. And that's why I had 3 here. I'll erase that. Right. And remember, guys, for arguments of complex numbers, our principal values are between minus pi and pi, with minus pi not included. So there you go. You have to remember this. And so the argument of u star is tan inverse of 1/3, while the argument of u is tan inverse of minus 1/3. And tan inverse of minus 1/3 can be found, if you don't know it directly, well, you could also check in the calculator that this gives you twice tan inverse of 1/3. However, I think there is a nicer way to do it, and it's by looking at the graph of tan inverse of x. So if you look at the graph of tan inverse of x plotted here, then clearly, so it should pass through the origin, clearly the graph is symmetric about the origin. So tan inverse of 1/3, which is here, say, would be minus tan inverse of minus 1/3, which is over here. Right, so the graph is symmetric about the origin, which is the same as saying that the function is an odd function. So, which proves this relationship. So then we obtain our proof that tan inverse of 3/4 is twice tan inverse of 1/3. So that's it for today. I'm sorry about jumping a bit everywhere, but this was to essentially prove all the results that I used. Thanks a lot, and see